Hello friends, I'm Professor Swanand Nogre, and in this video we are going to study the voltage divider bias or the cell bias circuit of BJT. So here, what is the meaning of biasing? Biasing means to connect a DC supply in a transistor in a such a way that the two junctions in a transistor, that is emitter base junction and collector base junction, will be either forward bias or reverse bias. And if both are forward bias, the transistor will operate in saturation region, it will act as an on switch. If both are reverse bias, transistor will operate in cutoff region and it will act as an open switch. And if emitter base junction is forward bias, emitter base junction is forward bias and collector base junction is reverse bias, then transistor will operate in active region and it will act as an amplifier. So first, in common, let us consider the common emitter configuration of transistor, because it is widely used, and NPN transistor, because the electrons are the majority charge carriers in the NPN transistor and the electron mobility is greater than the hole mobility. So here we have seen the basic biasing circuit of the common emitter configuration. So here the base is the input terminal, right? Then we are having the collector, which is the common the emitter is the common terminal, then collector is the output terminal. So here I am having the collector, then base is input, emitter as the output. And if I show here the basic biasing circuit, there is one resistor in series with the base, which is input terminal, and here the resistor is RB, and there is one supply in between the base terminal and the emitter terminal, that is input and common terminal. Then there is one resistor in series with the output terminal, collector terminal, that is RC, and there is one more supply in between output and common terminal, that is collector and emitter terminal. So here, with the help, as it is NPN transistor, NPN, we have to adjust the polarity of this VBB and this VCC so that the base emitter junction is forward bias and collector base junction is reverse bias. So here for NPN transistor, these polarities are like this. Here I am having positive, negative VBB, and here plus minus VCC. So this is the basic biasing circuit of common emitter configuration. Now what is the problem with this basic biasing circuit? Yeah, it can work, but there are some problems associated with. In last video we have seen the DC load line and Q point, and Q point is DC operating point, it is biasing point, and it should be stable. If there is variations in the location of Q point, what will happen? Though you have biased that transistor in the middle region of the middle region of this output characteristics of DC load line, what will happen? Though you have biased this Q point in the middle in active region, but if there are variations in this Q point, how you will get the variations in the Q point? If there is variation in the temperature of transistor, if there is variations in the inflow fluctuations, if the input contains DC, or you may have that Q point, if you replace one transistor with another transistor of same number, what will happen? They may have slight change in the values of the current gain, and hence you may have the slight change in the location of Q point. So what will happen? Though you have biased this transistor in active region, right? Q point is in middle active region, but you may have some fluctuations in the location of Q point. So when you use it in the application, means as a switch or as an amplifier, what will happen? This Q point, it may go in cutoff region or it may go to the saturation region, and there will be the clippings in the output. So this is the problem. So that is why this Q point should be stable, and with the help of this basic biasing circuit, you are not getting as good as the stability in the Q point. Hence we are using a new circuit for biasing of the transistor, and which is known as voltage divider bias or cell bias, and this circuit is having highest stability of Q point among all the biasing circuits. So that is why it is most widely used. So if I consider here voltage divider bias circuit. So obviously, again I'll draw here the symbol of transistor, base on left hand side because it is input terminal, right? Then collector, then the emitter, right? Now what is voltage divider bias? So there are two resistors, R1 and R2, right, which is acting as a voltage divider. I'll explain it, right? Then here I am giving a single supply, that is plus VCC, and there is one resistor in series with collector, that is RC. There is another resistor in series with emitter, that is RE, and I am connecting a single DC supply, which is VCC, which is in between this collector base point and the emitter base point. So this point is at zero potential with respect to this point. Here the DC voltage is plus VCC, and here instead of using these two different supplies, I have used the single supply. So that is why it is called cell bias circuit. That is why it is called cell bias circuit, right? And how it is acting as a voltage divider? See here, we know that here the input current is base current. In this circuit, input current is base current, and base current is very small. It is in microampere range. So that is why this base current can be neglected. So that is why the current which is flowing from this, say R1, right, when it reaches to this base junction, there is minimum very small current, ideally zero current, is flowing through the inside the base terminal. Hence the remaining current which is flowing through R2, it is same as that of the current flowing through R1. So that is why the current flowing through R1 and R2, they are nearly equal to same, and if the current is same, we know that it is series combination. Hence that is why R1 and R2, they are in series. Across this series combination, the potential applied is VCC. So what will be the voltage at base terminal? Voltage at base terminal, it is nothing but the voltage across R2, that is R2 divided by R1 plus R2 into total applied voltage VCC. So that is why this R1 and R2, they are forming voltage divider. Hence this circuit is known as voltage divider bias. Why we are using voltage divider bias circuit? Due to the highest stability of Q point, and you know though the Q point location is very important for the operation of transistor. So that is why it is most widely used biasing circuit. You can use this basic circuit for the biasing also, but there will be some problem. You may have the variations in Q point. So that is why this voltage divider bias circuit is used. It is more preferably used practically. Thank you.